I hope everyone's having a great day. I'm Mr. Ish. Thank you for joining me. How long has it been since anyone looked at one of these? A trigonometric function having that form, the standard form, you have a sine bx minus c plus d. It could be a sine or a cosine. There are various elements over here which you can analyze, and we will. In this particular video, we can just look at two examples, one with the sine, one with the cosine. When you're looking at this, the first thing you probably want to do is look at the domain. Sine always has a domain minus infinity to infinity, so that's done, it's easy. The next thing you probably want to look at is your amplitude, which is usually in absolute value. This right here represents your amplitude. It's going to be 3. Your sine function here, however it would look, it would be 3 above and 3 below based on your line of axis. And line of axis is not always your x-axis here. Line of axis, because of that, will really be your y equals 1. You would have a function which will be 3 above and 3 below from there. But you can picture this in your mind. Just understand that the amplitude here is 3. What's another thing we want to look at? How about the period? Period, you know, comes from 2 pi over b. What's our b value? You see it right here. It's 2. 2 pi over 2, meaning it's pi. Instead of the normal 2 pi period of a sine and a cosine function, this is just pi, so it's half as long. You can fit 2 of these in one of those sine x functions. 2 of these in one of those in terms of length. How about phase shift? Horizontal translation. Well, you look at that from c over b. You have a c value, you have a b value. C over here is pi, b value is 2, but you have a minus sign that tells you you're horizontally shifted to the right by pi over 2 units. A standard point on your this function will be on this curve right here, pi over 2 to the right, and then it'll also be 1 unit up because of that vertical translation. That's how each point will show up in this modified function right here. Vertical translation, well, we're plus 1, we see a d value here plus 1, so that's easy. What's another thing we can look at? How about range? You know, the normal function here is a minus 1 to 1, but this is definitely not that. You're going to look at everything here as d plus minus absolute value of a. D over here is a 1. 1 plus minus absolute value of 3. You can open this up. You'll have 1 plus 3, which is a 4, and you'll have 1 minus 3, which is a minus 2. So your lowest point will be a minus 2, but your highest point will be a 4. And that'll complete it for this. Lastly, you can always determine the interval. You know the interval comes from bx minus c is equal to 0 and 2 pi. We do have a bx minus c. It's 2x minus pi is equal to 0 and 2 pi. When you solve this out, x is equal to pi over 2 and 3 pi over 2. Single wave will have a starting point at pi over 2 and an end at 3 pi over 2. The difference of these two right over here will give you your period pi. 3 pi over 2 minus pi over 2 is indeed pi. The difference of this is your pi, your period. And that's about all you'd want to determine for this function right here. The domain, the amplitude, the period, phase shift, vertical translation, range, and in the interval. The interval can usually be written here with square parentheses, so it would be better. Let's look at one more just for practice for this particular video. Let's look at this. 1 over 2 cosine x over 2 minus pi over 2. Not too hard. Domain always, unless otherwise stated, as minus infinity to positive infinity. That's the easiest thing. All real numbers is a domain of sine and the cosine because they go on forever. All real numbers is your domain. What about the amplitude? We have 1 over 2. It'll be half as tall as your regular cosine, which would have an amplitude of 1. This right here has an amplitude of a half. It's half as tall. From the line of axis, it'll be half up and it'll be half down. That's exactly how your amplitude would show up. Period. 2 pi over b. What's b? 2 pi over 1 over 2. Flip it around, you get 4 pi. A single wave of this would have twice the size of your regular cosine function, which is just cosine x. This has a period of 2 pi, this is 4 pi, this is twice as long. The wavelength is twice as long. How about phase shift? C over b. You have a pi over 2 divided by 1 over 2. Pi over 2 times 2. You have a phase shift here again to the right because of this negative sign. If this was a positive, it would be a phase shift to the left by pi units. Your standard point, if supposedly on the cosine function, as you know, it's 0 comma 1 as your standard point, this same point would be pi units in this direction. It would become, that same point would be pi comma 1. That would be your standard point right over here. Translated to the left by pi units phase shift. There's no translation here, vertical translation, so every single point would be always pi units to the right based on the standard function that you're seeing right over there. What remains over here now? We have the domain, amplitude, period, phase shift. How about we do range? I'm not doing vertical translation because there is no vertical translation, it's a 0. But range over here, you know it's d plus and minus a. D is a 0 plus and minus 1 over 2, which will just be minus 1 over 2 and 1 over 2. In contrast to the minus 1 and 1 of a regular cosine. There's no vertical translation, your range is just shorter. Minus half to half. That's it, not bad. Interval. You will do bx minus c is equal to 0 and 2 pi. You have your bx minus c. You have x over 2 minus pi over 2 is equal to 0 and 2 pi. If x over 2 minus pi over 2 is equal to 0, you solve for the first one. X over 2 is equal to pi over 2 and x is equal to pi. Well, that's your start of one wave in terms of the interval. And then you do the same thing with equal to 2 pi. X over 2 is equal to pi over 2 plus 2 pi. And you know you can do that. You'll have a common denominator here, pi plus 4 pi over 2, and you multiply by 2 because this will go across. You'll basically have over here a 5 pi. So your interval here would be represented as a pi and a 5 pi. Your standard wave would have a starting point right here and would have an end point right here. The difference of these two would be your period, which is 4 pi. 5 pi minus pi is a 4 pi. This represents the start and the end of your standard wave, your wavelet within this function over here. A single wave that you would want to bring out from here as your standard from which you can do your comparisons, it would be represented by this interval right over here. And that right there brings us to the end of everything here with regards to this video. We have done some review over here. We've looked at the domain, the amplitude, the period, phase shift, range, interval for this function and the function right before. And that's it for this video. Thank you. Have a great day. Bye.